Hello everyone and welcome to lesson 7.2. We're going to take some time today to go over some terminology that we didn't cover in lesson 7.1 that we believe is important for you to know going forward, and especially for your A&T exam. So that being said, again, weight and balance, super important. It's what makes aircraft fly really, so we got to make sure that we keep that in mind. Let's go ahead and learn a little bit more. One thing that I briefly touched on, but I want to make sure that we understand here. You may remember this image from the last video. You'll notice that when we measure distances and when we're doing weight and balance, it's important to know the distance because, again, distance is part of that moment, that lever arm. The further a weight is away from that balance point or that center of gravity, the more it's going to tilt. A 40-pound gas can will have minimal effect here compared to having a 40-pound gas can being over here. It'll cause it to tilt on that fulcrum a little bit more. So naturally, since distance is so important, we need a good way to measure that. And one of the ways that we measure that is doing something called stations. A station is the location of an object on an aircraft along its longitudinal axis. So from forward going back in this direction. Now, something worth noting is that they'll very often measure this station from the datum. It's not measured from the center of gravity, it's measured from the datum. And remember, the datum, as we discussed earlier, is basically some arbitrary point that the manufacturer chooses. Some datums are in the center of the aircraft, some are where the firewall is, some are at the edge of a propeller, and some are where the nose is. It all depends on the situation, right? The stations are very often measured in inches. So again, you may notice that this front passenger seat in this diagram is 37 inches away from the datum, and that your center of gravity is 40 inches away from the datum. It's all measured in inches very often. Another thing you should notice as well is that these take on positive and negative values depending on what direction it is from our datum. So again, we have our datum right here, but you're going to notice that we have an oil tank that's 13.3 inches forward the datum. If it's forward of the datum, that's going to produce a negative distance or a negative moment. So again, make sure that you understand that signs do matter here. When we do math in the next lesson, you got to make sure your signs are correct. Super important. But then if you take a look again, we have the front passenger seat, the fuel tanks, and the center of gravity here. Those all have positive values because it's aft from the center. No, excuse me, it's aft from the datum. So back from the datum or aft from the datum, it's positive. Forward from the datum, it's negative. So again, all this information is super important. Let's keep that in mind with station. Now, let's move on. Speaking of locations, you're going to find some terminology, things like MAC, LEMAC, and TMAC. And that's actually very important information. So bottom line, why should we care? Very often, you'll notice that the center of gravity on an aircraft naturally occurs somewhere within the chord or the width of a wing. Like you could see here on this aircraft. You could see that the center of gravity is somewhere within the width of the wing over here as well. And because of that, wing-related terminology sometimes needs to be used to tell you exactly where the center of gravity is. And that's what where MAC, LEMAC, and TMAC come into play. So MAC means the mean aerodynamic chord. Mean, which you may know from math, means the average. Aerodynamic chord basically means the length of the crosswing section. So let's look at this diagram over here. You're going to notice that we're looking at an aircraft from above, and that we have the MAC right here, which is the width of the wing. Now, width of wing can be complicated. If you look at this diagram, you'll notice that the wing at this point is at its widest, but the width of the wing changes as you go further down. So which width do you take? Do you take the width at this end, or do you take the width at this end? That's why we do the mean, or the average. What we do is we take its longest and its shortage, we take that average, and we go off of that instead of taking one extreme or the other. So your MAC, or your mean aerodynamic chords right here. And essentially what we're saying here is that the MAC is the width of that cross section. We take that above aerial image view, we pretend to cut into the wing, and this is what the side of the wing, or the airfoil as we call it in industry, looks like. So the MAC is that width of the average length. LeMAC is essentially the leading edge, or the front side, the starting point. So the leading edge is right over here, where the wind starts hitting it, and the trailing edge is the other end, or the back end. So leading edge, trailing edge, and then the MAC is the distance in between. The leading edge MAC, the trailing edge MAC, the distances in between. Now, that's a lot to memorize, but let me just put it to you this way. In terms of stuff that you're going to see on the quiz, you're going to bump into the following things. First of all, you're going to notice that on a type certificate data sheet, they're going to give you the location of the MAC. And the MAC is very often defined as a distance or station from the datum. Again, we talked about station in the previous slide. So when you look at MAC information, you're going to see that it's the distance or the station from the datum. Keep that in mind. Second important thing you need to know is that the location of the center of gravity on the type certificate data sheet or pilot's operating handbook, wherever you find it, that's often given as a percentage of the MAC. So for example, 13% of the MAC. So what does that mean? Let's go back to this cross section for a sec. If you have 13% of the MAC, you're going to take this entire MAC width, and it's telling you that your center of gravity is about 13% in. Now again, I'm eyeballing this here, but you're going to see right here, this is about 12% of the MAC in this diagram, so 13% is slightly beyond that. So you know that your center of gravity is going to be right here. So visually, 13% of the MAC is 13% in, and we're starting from the leading edge. So we're starting from that leading edge. Notice we're not taking 13% and starting from the trailing edge and working in. We're starting from that leading edge and working in. So that's essentially what that means, and that's all you need to know about MAC, LeMAC, and TMAC. Got a couple quiz questions for you. Let's knock them out. Thank you for getting those done. Let's move on. Center of gravity range. We touched on this in the last lesson when I showed you the two analogies, the one with the fork and the cork, and how your center of gravity changes when you add weight in make moments in certain locations. And I also showed you it with the example of Mark Rober picking up a basketball. You're going to see that these edges of the line right here represent the range of where the center of gravity needs to be. The center of gravity on Mark Rober's body is right here, and as he moves back and forth, if he tilts over too far forward, it's going to cause him to fall over if he is outside of that center of gravity range. In like manner, for an aircraft to work properly, that balance, and to be balanced, it's got to stay within that operating center of gravity range. Think of those red lines. And I have a few visuals here that are helpful to you. So again, you may remember that wing diagram I showed you before. You're going to see over here that we have a center of gravity forward and a center of gravity aft. That means your center of gravity is stuck in between this range, this operating range right here, in order to balance. You can also see that done in terms of a graph over here. Keep this in mind, you're going to be using this a lot later. And then you can even see an example of where you find this information in a pilot's operating handbook. I have this excerpt here from a Cessna 152. So again, it tells you what the forward center of gravity limit is and the backward or the aft center of gravity limit is. Keep it in between there, you should be fine. So that being said, you understand CG range, you understand station, you understand LeMAC, TMAC, and MAC. Let's move on. Weights. So there's some important terms you need to understand in terms of weight that I haven't described to you yet. So we have the empty weight of the aircraft. You already know what that means. It's essentially the weight of all the stuff that's fixed to the aircraft. Airframe, power plant, fixed appliances, fixed ballast, which, by the way, we'll discuss ballast in a second there, so hold your horses there. You have, also important to know, unusable fuel and undrainable oil are included in the empty weight. So They do the best they can to drain the fuel and drain the oil, but if there's still stuff left in the tubes and in the system, they include that as part of the empty weight, just so you know. We have useful load. And again, I have this diagram right here that really helps it. So you have an empty aircraft, and then you have all the stuff that you're going to put on it on a trip. Stuff like the passengers, baggage, the pilot, oil and gas. All of that is your useful load. It's essentially the stuff that the empty aircraft transports. Another way you could think about it mathematically is that it's the difference between the maximum weight that the plane could take and the empty weight. So you have the maximum weight the plane can take. You have the empty weight of the aircraft itself. The useful load is everything that it can transport without being out of limits. Maximum weight is essentially that maximum authorized weight of the aircraft. You do need to understand that in different phases of flight, there are different maximum weights. For example, when you're on the ramp and you're taxiing over to the runway, there's a maximum ramp weight. But naturally, when you're taxiing over to the runway, you lose weight due to oil and gas burning and stuff like that. And when that happens, then you have a new weight, which is your maximum takeoff weight. You have to have a certain maximum takeoff weight before you start getting off the runway. After that's done, then you also have a max landing weight. You have to lose a certain amount of weight during the flight in order to safely land. And the reason why is because, well, landing is very structurally strenuous on an aircraft, and if you have too much weight, it could compromise the structure of the aircraft. One thing you should know is that most modern aircraft are designed in such a way that if you have full fuel tanks, full baggage, full amount of passengers, you're often going to be in excess of the max takeoff weight. So the aircraft loaders, the pilots, they have to work in the aviation mechanics. They have to work together in tandem to make sure that they hit a sweet spot of max weight while optimizing the amount of passengers, baggage, and fuel. It's a hard balance, and they have professionals that dedicate their whole careers to doing this. But again, super important. Another thing mentioned in here is that we have the zero fuel weight. And the zero fuel weight basically means that you have your maximum weight, again, everything in here, but you're taking away the gas. You're taking away that fuel. So if you take a look over here, we know that useful load is all the passengers. We know that empty weight is the empty aircraft, and we know the maximum weight is all of them together. But if we take that maximum weight and subtract the fuel, then we have what's called a zero fuel weight, and we're left with just an empty aircraft, the passengers, the baggage, and the pilot. So again, make sure you understand those terms. Why don't you go ahead and answer some questions for me? Thank you for getting those done. Now let's wrap it up. Weights. These are important terms to know. Ballast. So here's the thing. If you find your ballast can be temporary or fixed, but what it means is that you're adding weight to an airplane, or an aircraft rather, to help it stay within that proper CG range, that proper balance. Think of it like adding weight to a seesaw to get it in balance. It's the same idea, but you're doing it with aircraft. So you have temporary ballast. Sometimes aircraft operators will toss sandbags into an aircraft to help maintain that balance and get it in the proper CG range. Other times you'll have fixed ballast, which is when you're literally installing a permanent piece of equipment that goes on the plane that's meant to be ballast. That'll very often be in the form of plates, and you can see a diagram of that on a typical helicopter right here. Another thing about weights that's important is that very often assumptions will be made about the weights of things to simplify weight and balance calculations, because frankly they don't have a ton of time to actually weigh every passenger and weigh every bag. I mean, they'll weigh every bag at your average airport, but often they have to make assumptions to simplify things, for better and for worse. So you'll notice that these are some basic assumptions here. We have aviation gas at 6 pounds per gallon, oil at 7.5, water at 8.35, and crew and passengers are usually assumed to be about 170 pounds per person. And that's basically it. Thanks for working with me. We'll see you on the next video. Clancy over and out.